In this lesson, we're going to consider what we mean by a parallel circuit. In the last lesson, we looked at series circuits. We remember how you can park cars in series, for example, nose to tail, nose to tail. Well, if I were to park these cars in parallel, okay, then I would park them in this way. Now, it's the same sort of thing when I connect the components of a parallel circuit. So we remember in the last unit we started off with this simple circuit where in fact at this moment the light bulb is connected in series to the battery. If I want to connect another light bulb, not in series but in parallel to this light bulb, then the circuit will look like this. Now, to understand what happens when I close the switches of this circuit, I want us to think about the electrical potential. That's to say, and the electrical potential difference. So let's think about the electrical potential in this circuit. We have here a battery. It's a 9-volt battery, and that means that the electrical potential of the positive terminal is 9 volts. The electrical potential of the negative terminal is 0 volts. Now, I'm going to close the switch, right, and let's find out what is the electrical potential across this light bulb. Okay, let's close that switch as well, so current flows, and we can see that there is nothing between this light bulb and the positive terminal of the battery. There's no component in it in this path, so there's nothing to change the electrical potential energy. So the potential energy must be 9 volts here, it must be 9 volts here, here, and here. So we can write 9 volts. Right? Likewise, it will be 0 volts here, here, here. Okay, and 0 volts. So if I want to measure the potential difference across that light bulb, I take my voltmeter, I measure that, place it there in parallel with the light bulb, and I find that the potential difference is 9 volts. Now then, if I come along and I close this switch, well, we see now that this light bulb, okay, have a look at what will the potential be at this point. Well, clearly, again, if you follow along the circuit, you'll see there's nothing in between that light bulb and the positive terminal of the battery. Nothing. So the potential must be 9 volts all the way around here up to here. So this must also have a potential of 9 volts, and likewise there is nothing separating this terminal of the light bulb with the negative terminal of the battery, which is at 0 volts. So this must also have a potential of 0 volts. I measure the potential difference across that light bulb, and that will also measure 9 volts. So in the parallel circuit, the potential difference across each light bulb as it's connected in parallel remains the same. So we can summarize that by saying for components that are connected in parallel to the battery, then the electrical potential difference across each component, in this case across each light bulb, is the same. And what about the current? What happens to the currents in a parallel circuit? Now, let's suppose that I close the mother switch here in this circuit and the switch in this branch, but this branch is open at the moment. So the current will flow again in an anti-clockwise direction around this part of the circuit, and if I measure the current with an ammeter, a current of 1 amp is flowing through this ammeter, is flowing around this circuit and through this light bulb. Okay, nothing will flow down here because this switch is open at the moment. Now what happens when I close this switch? Then the current flowing through this light bulb will also be 1 amp. Okay, so we have 1 amp flowing down here. All right. And we'll have 1 amp flowing through this light bulb. But because we've got 1 amp flowing down here and 1 amp flowing down this way, then we must have in this initial part of the circuit, we must have now a current of 2 amps flowing, since these 2 amps must at this point divide into 1 amp going this way and 1 amp going that way. And likewise, the 1 amp flowing at this branch and the 1 amp flowing across this branch will meet to form a current of 2 amps again flowing back into the battery. So the 2 amps divide here and then join up again at that point. So what does that mean about the brightness of the light bulbs? Well, since in a parallel circuit it doesn't matter how many light bulbs you connect in parallel, you will always have the same electrical potential difference across each light bulb. In this case it will be 9 volts, and again across this one it will be 9 volts, and if I add another light bulb to the circuit it will still be 9 volts. You will also have the same current flowing through each light bulb. Okay, we'll still have 1 amp flowing through here, and then 1 amp flowing through here, and then 1 amp flowing through an additional light bulb if we add that. So the brightnesses of the light bulbs will still be the same. They will not be affected each time we connect a light bulb in series. You can see a video of this in the Watch and Learn section under Electricity 2, where we connect light bulbs in parallel and compare that with when we connect light bulbs in series. So to summarise, when identical light bulbs are connected in parallel, we can say that the current flowing through each light bulb is the same. And since the electrical potential difference across each light bulb is also the same, then the brightness of each light bulb is the same. So the brightness of the light bulbs are not affected by the number of light bulbs I connect in parallel. I can just keep on connecting one after the other. And that precisely is the type of circuit that is used for the lighting circuit in your house. So you would not connect the light bulbs in series like that, because each time you did so, each time you added another light bulb to a series circuit, you increase the resistance, reduce the current, and so the light bulbs would be dimmer. Now, another reason why you'd never connect a lighting circuit in series is that if, these 3 light bulbs are on, and supposing that for some reason one of the light bulbs blows, bang, like that, well, that means that the circuit would be broken and a current would not be able to flow around the circuit, so the other light bulbs would also go out. Now, this is not the case in a parallel circuit. So, we'll put the mother switch on here. If I connect this light bulb on, and then this light bulb on, and then this light bulb on, they all light up with the same brightness. Okay, assuming they're identical light bulbs. Right. But if for some reason this light bulb happens to blow, then it does not affect the current passing through the other light bulbs. So that's another good reason why you would use a parallel circuit for a lighting circuit such as that in your house.